Hello, good evening, all. Can you hear me?
Good evening, ma'am.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Press on my screen. We'll start in a minute.
Ma'am, is the session for week 5 or week 6?
This is for week 6. Week 5 is done, right?
Okay, ma'am.
Yeah. This is week 6. Are you able to see my screen?
Yes, ma'am.
Yes.
Did you watch the lectures?
Yes, ma'am.
Okay.
Yes, ma'am.
No, ma'am.
No?
Ma'am, will you be taking doubts?
Uh, so today generally we discuss the content which is given in the lecture. So
Okay.
yeah. So in week 5, what all did you study? So week 5 you studied factorial, right? You have studied basic
Yes,
principles
ma'am.
of counting, right?
Counting prince.
Counting principles you have studied. So now in week 6, we are just extending it a little further, and we are going to talk about there are two methods of counting. One is counting with order, and the other is counting without order. So counting with order means order matters there, and counting without order, when I'm saying, means order does not matter. Okay. So the first thing is the first thing you have is permutation, which is nothing but arrangement. Like whenever you are interested in arranging something, then you talk about uh, permutation basically. So permutation is an order arrangement of all or some of n objects. So given an n object, if you want to, let's say you have uh okay, let's say um you have, let's say, 5 objects, okay, and you want to arrange these objects in some manner. You just want to make the arrangement. So you want to know in how many ways can you do such arrangements. So whenever you have to find the numbers like that, you're dealing with permutation there. So either the question can be asked like you want to arrange all the objects, or maybe you want to take two objects from there and know how many ways can you arrange this, or maybe you want to take 4 objects from there and you want to know how many ways can you arrange it. Okay, so there are situations like this that may come. So we have started with you will look at two cases. So there will be two cases. The first thing is we are talking about here uh, the distinct objects. So case one is I'm going to talk about first is distinct objects. Permutation when objects are distinct. And the second is permutation when objects are not distinct. Okay. So first let's look at the case when you have distinct objects. So distinct objects as in like the case that we saw. Let's say you have distinct objects 1, 2, 3, 4, 5. You know that all these 5 objects are different, distinct, and you want to make the arrangement for that. So first we look at cases like that where the objects that are given to you are distinct. Okay, and then again you can partition it into two parts. So it will be like first will be when the repetition is allowed. Repetition allowed, and the second would be repetition not allowed. Okay, so this is what I have written over here. So case one, when objects are distinct, this is what we're going to talk about first. And in that, first we're talking about when the situations where repetitions are not allowed, then how do you make the arrangement of that object? So very simple examples we had started with. So let's say we have we have a set. where you have elements A, B, and C, right? And you have to find all the possible arrangements that you can make with these three objects. So the first is like, if you have to make all the possible arrangement of these three objects and taking all three at a time, then how many ways can you do it? So can you tell me like what all possible cases you can have? Sorry. I'm not able to hear you.
Is it 6, ma'am?
It is 6, but I'm asking like what all objects are there? I mean, what all arrangements are possible? You see, whatever we are doing right now, if you have watched the lecture, you should know all this. So even if you have not watched the lectures, just follow with me whatever I'm saying and try to understand if it makes sense. Yeah. So yeah, what I'm asking here is, now you have three objects A, B, and C, and you want to arrange these three objects. Okay, so can you tell me, somebody said six cases are possible.
Ma'am, 3 factorial.
3 factorial. Okay, so 3 factorial is 6 only, right? 6 cases are possible. I'm not
Yes,
asking
ma'am.
how many, I'm asking what all are possible. Like how many?
Ma'am, A, B,
Ma'am,
C.
A, B, C, A, C, B,
A, B, C, A, C, B, B, A, C,
B,
B,
A,
C, A.
C,
Hmm.
CAB.
C, A, B.
C, A, B,
CBA.
C, B, A,
So yeah, so it
6.
was a
B,
very,
A.
CBA,
yeah.
it's A.
Sorry.
Last
Ma'am,
one.
last one, C nahi, A.
Okay. Yeah, right. So these things are quite simple. I mean, given such small example, it's very easy to find it's very easy to find how many ways can you arrange it. But in general, when you solve the problems, you will not have things like that. You will be given like very like big numbers, and in that case you'll have to understand like whether you are whether what you have to use, whether order matters here, order is not matter here. You have to consider all these cases, right? So this was very short example. Now the next is, what happens when you take two objects at a time? So when you take two,
Also 6, ma'am.
how many?
6.
3. So it will be A, B,
Yes.
B, C,
C.
A, A, C, right? C, B, and
Yes,
what?
B,
ma'am.
A.
B, A. So again 6. So
Yes,
again
ma'am.
6 are possible. So we saw that here order matters. I mean, it's not like that since we have written AB, so we cannot take BA. I mean, we'll have to consider BA also, because we are interested in arranging the objects, right? So whenever we are interested in arrangements, in that case, order matters. It matters like whether A is first or B is second, or B is first, A is second. So in general, when you want to send it, so like when we say we have n distinct objects, then what all possible permutations, what is the number of permutations that are possible when you have to add objects from a collection of n distinct objects?
NPR.
Yeah, NPR. This we denote it as NPR, and what it is given as n factorial by
N minus R.
n minus
N
r.
minus R.
R factorial.
R factor.
Yeah. So if you look at these two examples, in this case, we had to select n was 3 and you had to select 2 objects. So we did 3p2, right? We arranged it. So it is 3. And this is nothing but 3
3
factorial,
factorial.
1 factorial, which is nothing but 6. And if you look at this first example, in this case, we had n equal 3, r equal 1. So again, np1 is nothing but 3 factorial, right?
Ma'am, here R equal to 1.
Ma'am.
Ma'am, R is also 3.
Sorry, r is 3. Yeah, thanks. This is r is 3. So
0 factorial is 1.
3p3. So 3 factorial by 0 factorial, which is 6.
3 factorial.
And you know that 0 factorial is also 1.
Yeah.
Okay. All right. So we have this example over here. So it says from a committee of 8 persons, how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position?
56.
56.
56. How is it 56?
Yes, ma'am.
Ma'am,
8 factorial.
8 into 7. Simply we apply counting principle.
8 into 7. Can someone repeat? Why is it 8 into 7?
Ma'am, because for chairman we can choose out of 8 people, and for vice chairman we can choose out of 7 people, as we have already made that person as our chairman.
Permutation is not happening.
We done it by counting principle, first we saw in a week 5.
Yeah, so you have 8 people. And you have 8 people, but you have just 2 positions. So you want to fill this 2 position. So the first one you can fill with 8 and the second one 7. So just 8 times 7. And since it is also mentioned that one person cannot hold more than one position. So that's why it is also
Ma'am,
7.
we can also use the formula, the above
You can
formula.
also
ma'am.
use the formula.
Yes, 8p2.
So you have
I have a doubt.
So n
8
is what?
factorial upon 6 factorial.
N is 8
8.
and R
R
is
is 2.
2.
so 8
8
people is what?
factorial.
Yes.
8 factorial by 2 factorial. And this is
6
sorry, 8
factorial.
6 factorial. 6
Ma'am,
factorial.
6 factorial. Yes, ma'am.
And this is just 8 times 7 factorial. 7 times 6 factorial divided by 6 factorial, and it gets cancelled out. It is 56.
Ma'am, what about the chairman and the vice chairman arrangement in this question also matter or not?
In this case,
Yes, ma'am.
so okay. So here it matters, right? I mean, we are asking like you have to choose like from a group of 8 people, you have to select 2 person, right? One position is for chairman. So let's say one position is for chairman and other is for vice chairman. So it matters if whether you put the chairman, I mean, whether this is chairman or this is vice chairman or this is vice chairman or this is chairman. It will matter, right?
Yeah.
Yeah. So that is why we are using the permutation here. But we'll go when order does not matter. But here it matters. It matters that which person you choose as chairman and which as vice chairman. So that is why you're using permutation. But even if, let's say, you did not know that what is permutation, then still, I mean, if I tell you that there are 2 positions, right? And there are 8 people who has to, like, for these 2 seats, you have to select people from these 8 people, 8% that you have in the committee. Now, we are also saying that one person cannot hold more than one position, right? So if let's say one person is at this position, then the person cannot be at the second position also. So for the first position, let's say for chairman, let's say I have 8 choices. So is for the second one, I have only 7 people left. So I'll just do 7. So it's just 56. I think this you would have studied in week 5.
And even it is 8p2 into 2p1,
8p2 into
2p1,
2p1.
because I will choose in a chairman and a vice chairman, 2 position into a 1.
No. I mean, see, you have just chairman and the vice chairman, right? Two positions you have.
Okay, ma'am.
So
Got it.
either you choose, I mean, the person you choose, either it can be chairman or it can be vice chairman, right?
Yeah, ma'am.
So here the order will matter. Who you choose as chairman and who you choose as vice chairman. Okay. Okay, let's say I tell you okay, I think it is fine. Okay. Let's look at the second question. So in the second question, it is asked, find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5. And if no digit is
5
repeated,
factorial.
5 factorial.
120.
20 ways.
120, ma'am.
Yes, 125
120.
factorial. Same thing.
So how did you find this?
5p4 permutation.
Same
5p4.
by counting
I-
principle.
And then it will be 5, no?
No, that is what? 5p4 is what? 5
5
factorial.
factorial by 1 factorial.
5
Oh,
minus
right.
4 factorial, which is 1 factorial. So this is
Yes.
5 factorial.
120.
But if you have to find the even numbers, then what will you do? Now what I'm saying is you have 4 digits. You have to make a 4-digit number out of these 5 numbers. Okay. So how many even numbers can you make?
4 factorial into 2.
4 factorial into 2. Okay. Anybody else?
4 into 3 into 2 into 2.
4 into 3 into 2 into 2. Okay.
Ma'am, I think it is 40. It is the way I am actually visualizing
Ma'am,
it.
48.
Ma'am,
48.
48.
48.
No, I'm not asking the answer. I'm asking what you're going to write.
Yeah, so this is how I am visualizing, ma'am. Out of the 5 digits, we need to form 4-digit numbers first. So out of the 4-digit number, last number for it to be even, we have only 2 choices, 2 and 4. So I'm ignoring the 4th digit. Now I'm trying to formulate a 3-digit number first from this 5, which will be 5p3. So 5p3 will give me the number of 3-digit numbers that I can form out of this 5. And then I know last digit can be either 2 or 4. So into 2. So that is giving me 40.
40.
Yeah. Because
Ma'am,
5p3 is giving me,
Okay, you are doing the 5p3 here.
yeah, 5p3 into
Okay.
2. 5p3 into 2, ma'am.
Okay. And 5p3 is 5 factorial by 2 factorial, which is nothing but 5 into 4 into
Oh,
3.
yeah, I missed the 3. Okay, so 60 into 2.
120.
120. Again, I'm getting 120.
48 answer. You can't use 5, na? One digit
This
will get
method will
repeated.
use 4 and 2.
Okay.
24.
Use
I
4p3.
think.
4p3.
4p3 into 2p1.
4p3 into
Yeah, correct.
yeah. So
That's
this
That
will
would be
work.
the answer.
Yeah. So this will give what? 4 factorial by 1 factorial. So 424 times 248. So see, here you had how many? You have two even numbers, right? So you know that you'll have to fix you'll have to fix 2 over here. 2 numbers are only possible, either 2 or 4, because the number has to be even.
Correct.
And the remaining that you have, so from there, so whatever you fix here, either 2 or 4, now you have to out of those 4 numbers, you have to select 3, right? Because we are also saying no digits are repeated. So if no digits are repeated, whatever you have fixed at this place, the last place or the ones place that we say, so the remaining 3 that we have, there you have to select, from there you have to select 3 times 2. So it just 4p3 times 2p1.
Ma'am, you wrote C.
Oh, sorry. Yeah, thanks. 4.
Ma'am, actually, one more doubt, ma'am. See, okay, you whatever you explained here. So fourth digit, it has to be 2 or 4. So we are ignoring the digit. Then, if we ignore that digit, we need to form 3-digit numbers, and so P3. And the available choices are how 4, ma'am?
How 4? Because 1 you are fixing here, no?
Well, what is 1 I'm fixing?
What I'm saying is like
Ma'am, this 4 is the number of numbers available for me, right?
Numbers available for?
Number of numbers available for me to form a number, right? Digits available.
You had 1, 2, 3, 4, 5, right? Now from here, I have to make only you use only 4 digits, right? Because no digits are repeated also.
Right.
Now I know since I have to make the even number.
Correct.
The number which is going to be at one's place is either 2 or 4.
Yeah, till then agree, ma'am. Till then.
So let's fix 1.
Yeah.
So whatever it is just going to be 1, right? So remaining you will be left with 3, 4 more numbers.
No. Why should it be only 1, ma'am? It can be 2 or 4, right?
Yeah, that is right. But still, whatever you fix, you still have 4 numbers left, right? Let's say I fix 2. Then what number you have? You have 1, 3, 4, 5 left. Let's say if I fix 4, then I have 1, 2, 3, 5 left. And from there, now I will select 3 numbers. And from there, I now select 3 numbers. Either is possible.
Yeah,
okay. So on the same line, let's say I give you, tell me how many odd numbers are possible. So what would be the answer?
120 minus 48.
120 minus 48. Okay. Anyone else?
4p3 into
4p2
3p1.
into 3.
60.
Ma'am, 4p2 into
4p3 into
4p2 into 3,
4
ma'am.
into 3 into 2 into
No, it would be 4p3 into 3p1.
4p2.
4p3 3
4p3
into 2 into 3, ma'am.
into 3p1.
Into 3p1. That would be the right. Yeah.
So it is 72.
Yeah. 72.
72.
Yes.
All right. Okay. So next is the next question is 6 people go to the cinema. They sit in a row with 10 seats. Find the number of ways in which the following can be performed. The first is they can sit anywhere. So we have
10p3, ma'am.
10p3.
10p6. 10p6.
Yes, ma'am. 10p6.
10p6, ma'am.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. and we have 6 people. And if they can sit anywhere, so I mean, we have it's like 10 distinct objects, and you have to arrange 6 objects there. So it's 10p3. Right? Now the next is
Ma'am, 10p6 or 10p3?
Ma'am, 10p.
10p6, ma'am.
sorry, I'm writing wrong.
Okay.
10p6. Yeah. Next is all the empty seats are next to each other.
10p7, ma'am.
6p6.
10p7.
10p7.
7.
Yes,
Okay.
ma'am. Yes.
Why is that?
Because we
7p6.
consider whole empty as one
Ma'am,
element.
7p6.
7p6. Okay.
Ma'am,
I
6p6.
think, ma'am, 6p6
Ma'am,
into 2.
6p.
6p6 into 2.
6p6 into 2.
Yeah.
Ma'am, mine only 6p6.
Okay. A lot of answers. Okay. Any other answers? No? Okay. Let's see. So what we are saying is we have 10 seats, right? So out of these 10 seats, what we have to check is how many number of ways it is possible that all the empty seats are next to each other. So we know only 6 people are there. So there will be 4 empty seats for sure. Now there are 4 empty seats, and now what we want is that all these 4 empty seats are together. I mean, together as in, like, let's say all the people sit here. So we see that all these 4 empty seats, these are empty. Okay, nobody sat here. So all the empty seats are together. I mean, all the 4 seats are together. Now, other possibility could be that maybe everybody sat from this side, right? And all the 4 seats are empty, right? Then it is also possible that in between 4 seats are empty, and then 3 people sat on this side, 3 people sat on this side, and so on, right? So whatever it is, these 4 seats has to be together, right? So when you see it like that, it's more like you have 7 distinct objects, right? So you like first, second, third, together this is 4th, 5th, 6th, 7th. So you have 7 distinct objects, and you have to fix, I mean, how many people has to sit? So 6 people, right? So out of these 7, you have to arrange 6 objects.
Ma'am,
Right?
why
Like-
arranging 6 objects, ma'am? Is it not 7? You have 7 distinct objects. If you are arranging 6 objects, means you are also arranging 7th object, right?
Yeah, that is automatically, no?
Correct. So it shouldn't be considered as 7p6 or
7p6
sorry,
only.
7p7. I'm sorry.
7p7 is what? 7p7 would be 7 factorial, right? But okay.
So what I am saying is, ma'am, you have 7 objects, and you're saying we need to fix 6 objects. But fixing 6 objects is nothing but fixing the 7th object also, ma'am, right? I mean,
Yeah.
But we are choosing 6 now.
no, you are choosing 6. Means you are also fixing the 7th one. There is no choice. If you fix 6, the 7th one has to go there. There is nothing that you are doing anything specific, right? I mean, am I wrong? I'm just thinking.
Okay. So in the question, what has been asked is like 10 people, okay, 10 seats, and 6 people are there.
Correct.
And if we have to make 6 people sit in such a way that this all the seats, the 4 seats that are left, it should be at one place.
Correct. So that
Right.
means there is seventh object.
There is, that means there are 7 objects, and out of these 7 objects, now I have to arrange the 6 people. So, okay, let's see. Okay. So you have 1, 2, 3, 4, 5, 6, 7. You have 7 objects, and on like these 7 objects, you have to arrange 6 people. Right?
Correct, ma'am. Yeah.
7 objects. Sorry. Now n is 7 and r is 6 only, because you have to arrange 6. 6 objects you have to arrange out of these 7 places.
But ma'am, actually, this is where I'm differing. Actually, I just now thought about it. The answer would be same whether you consider R as 7 or 6. Answer is same. But per understanding, should R be 6 or 7 is the question. Because I mean, if you fix 6 objects out of 7, you are also fixing the 7th object position. You are not giving a choice. That's my point, madam.
Wait, I think I lost the connection between. Can you just repeat?
Yeah. No, so first my point, my observation is, ma'am, N7P6 is same as 7P7, which means whether we consider R as 6 or 7, answer is same. First thing. That's my first observation.
Okay. So let's.
Second observation is, when we are actually saying out of 7, we are fixing the position of 6 objects. You are also fixing the 7th object position indirectly. You are not giving a choice to it.
Okay. Let's see the same very simple example that we saw, right? We have 3 objects. Okay.
Yeah.
Now I have only 2 places. I mean, I want to arrange only 2 2 people over here. Right? So in that case, I had A, B, I had AC. You had 6 cases, right?
Correct.
And that was what? That was 3P.
3P2.
Okay, but this example may not work. Okay. What about you take maybe 4 objects? Then what happens in that case? So let's take A, B, C, D. So if you take 3P, not 3, 4P, 4P3.
Okay.
And 4P4.
Again, answer would be same, ma'am.
Yeah.
Because
Ma'am, but
three positions means you are indirectly fixing the 4th position.
Yeah. This will be same. This will always come same.
Yeah, actually, ma'am, the answer will be different. Answer will be different. Let's say when we want to fill in only 5 positions, leaving the 2, then you can leave those 2 anywhere. You have multiple possibilities. But here, you are actually considering all 4 seats into one object, which is unique.
Yeah, right. So NPR is same as NPR minus 1.
Yeah.
Yeah, that's true. Yeah. So both will give you the same answer. This is right. So NPR is same as NPR minus 1. So you
Why,
have.
ma'am, I didn't get that. How NPR is same as NPR minus 1?
I think she means by NP.
It is right over here because the difference between N and R is of 1. If the difference would be higher, it won't be same, huh?
Yes, ma'am. Please repeat once.
Yeah, okay.
No, basically NPN is same as NP
minus 1. Yeah. So I should write it as
NPN.
Yeah, NPN. Yeah, I should not write R. I should write
R,
NPN. Yeah.
Yes.
So what we are saying is that NPN is same as
NPN minus 1.
NPN minus 1. So here, okay. So So 10p7 is not right here, right? Because you want all the 4 seats to be together, which are empty. Now this is right, and 6p6 again is wrong, and 6, this is also wrong. This is also wrong. So either it's 7p6 or 7p7 is also right.
Ma'am, when to use P and C? Can you repeat this? Yeah,
What? Can you repeat?
when to use permutation and when to use combination?
When I come to combination, I will tell you.
Okay.
Let's finish.
And ma'am, I do have doubts from like lecture videos.
Tell me. So do you have doubt till what I'm doing is also from lecture video. Okay. So
Ma'am, in the tutorial, one problem I have issues with that, where there are 6 men and 4 women, and we have to form 3 couples out of them.
we'll come to question. Let's finish first the theory, whatever we have, and then we'll do, because for problems we have another session on Sunday also, right? So there also we can discuss. Okay.
Ma'am, do we have any session tomorrow?
Not tomorrow. Sunday we have one.
Okay, ma'am.
All right. So next we have when like what is the formula when you have n distinct object but repetition is allowed. So in the previous case we saw that the repetition was not allowed, but now what we are saying is the repetition is also allowed, right? So if I have, let's say, n objects, you have again n distinct objects, and again you have to arrange r objects from there. So, and if the repetitions are allowed, what will happen is, let's say I have 5 places to fill, right? So I can have 5 choices for this. Okay, 5 places to fill, and what I'm saying is, let's say n equal 10. So the first place can be filled by 10 objects. The second can also, even for the second place, 10 objects can come. Third also 10 places can come. So this is possible. So this is nothing but 10 to the power 5. So when you generalize this, when you are saying you have n distinct objects, and you have you want to make the possible permutations of our object, then in general, this is nothing but this comes out to be
n to the power r.
np to the power r. Okay. So in this case, the example that we did, so there n is n was 10 and r is 5. Okay. Okay. So let's see this question. It's the same one as ABC. Now here we are saying, in the previous case we said the repetitions are not allowed. Okay, but now if I have to arrange 3 places, and if I'm saying repetitions are also allowed, then how can you arrange these 3 objects?
I'm 3 raised to the power of 3.
3 raised to the power
3, ma'am.
3 raised to the power 3.
3 cube, ma'am.
3 cube, right? And what about the second one?
E square.
3 square.
3 square, right? So this one, you have 3 to the power 3 because you have 3 objects, and repetitions are allowed, and you have to arrange this ABC. So it is a 3 to the power 3. And in the second case, you have r to be 2. So you have 3 square. Like second case will look like this. So here you have 3. Even the second place, you can fill 3. So 3 into 3, which is 9. The first case, it looks something like this. So you have First place you can fill by 3 objects, either A, B, or C. Second also you can fill by either A, B, or C. Third also you can fill by either A, B, or C. So it is just 3 to the power 3. All right. So now we have the second case when objects are not distinct. I mean, previously whatever we saw, there all the objects we are considering to be distinct. But what happens when the objects are not distinct? Then in that case, how do you use this permutation formula? So what will happen here?
We divide by number of alike object.
Divided by common parts.
4 factorial by 2 factorial.
Yeah.
Can this be?
And 4 factorial by 2
The answer
factorial.
will be 4 factorial upon 2 factorial.
Yeah, that's
2
what I'm saying.
factorial.
We basically divide the factorial of the number of objects, items which are
Or of
repeating.
like common.
Right. So see, in this case, what is happening is you have to arrange data, rearrange this word data, right? So you have you see that A is occurring twice. So when you write all the possibilities, there will be and since A is appearing twice, so it will get just whatever you do, it will just get multiplied by 2. So you need to like make it, you have to get rid of that, and that's why you need to divide it by 2 factorial here. So you have just DAT, these 3 words, and A is occurring twice. So total number of so there are 4 letters here. So 4 factorial by, and 2 is appearing twice, so 2 factorial. So in general, like you have, let's say, any word, right? So for example,
Ma'am, here, I mean, how many ways can this be done? Means you have 4 letters, but they're actually truly only 3, right?
yeah.
Okay. And then how many ways can this be done? Means do we need to form 4-letter words, 3-letter words, or what is that actually? Is that clear from the question? I am not able to understand.
This is 4-letter word only. It just you have to rearrange the letters. So it's more like this is.
Then does it distinguish between placing the second A in the first place versus placing the 4th A in the first place? How do you distinguish that?
Okay, so see, you have 2A, you have D, you have T.
Correct.
If you think of it as distinct objects, okay, if you say this is my A1, this is my A2. So how does it look like? Like when I ask you to arrange these 4 letters, you will do A1, A2, DT, you will do A1, A2, TD, you will do A1, D, A2, T, you will do A1, D, T, A2, then you have A1, T, A2, D, you have A1, T, D, A2, right?
Yeah. Now, then how is this different from the previous case, ma'am?
Yeah. Now let's see. Now this is, we have written that, let's consider this as separate. Okay. So now if you write all the possibilities where A2 is coming first, then what happens? Then you will have A2, DT, A1, right? And if and this is more like this, right? Because we are saying all this because in actually both are A. You have AA, you don't have A1, A2, you have AA. So you see, again, this is repeating. So if you write all the possibilities, then you see I mean, twice it is like all whatever possibilities you write, everything is appearing twice. Can you say it here? Like,
Yes, ma'am.
sorry. Oh, sorry, I couldn't hear you.
Yes, I got it.
You got, yeah, okay. Yeah, so when you actually treat it as separate object and you write it, you will see that everything is appearing twice because this is not actually separate A1, A2, they are same thing. So you have to adjust that. And since you have two objects appearing, you have two objects which are same, you need to divide it by 2 factorial. So you get 4 factorial by 2 factorial. So in general, if you have, let's say, more in any word, like for example, we have here statistics, right? So in statistics, what is happening? You have ST, TIS, TICS. Here you have what all words are here? You have S, you have T, you have A, you have I, and you have C. And S is appearing 1, 2, 3 times. T is appearing 1, 2, 3 times. A is appearing 1 time. I is appearing 2 times. And C is appearing once. So total number of letters that are there in statistics is 10. So if I have to rearrange the letters in the word statistics, it will be 10 factorial and we divide it by everything that is repeating again. So in this case, it would be 3 factorial times 3 factorial, 1 factorial, 2 factorial, into 1 factorial. And this will give you the total possibilities. In this, the letters can be rearranged.
Ma'am, it will be multiplication or it will be in addition, like 3 factorial plus 3 factorial, then 2 factorial.
No, multiplication.
Okay. Okay.
So in general, like the first one is number of permutation of n objects when p of them are of one kind and rest are distinct. Then in that case, what did we see? We saw that it is n factorial by p factorial, right? And when you have n objects and you have p1 is of one kind, p2 is of another kind. So in that case, you have p1 factorial times p2 factorial up to maybe pk factorial. So you need to divide it by all the possibilities that are repeating. Okay. Then next is we have a circular permutation. So again in circular permutation, there are two possibilities. One is where clockwise and anti-clockwise are different. And so one is
Same.
clockwise and anti-clockwise same. Clockwise same. And the second is clockwise and anti-clockwise different. So again, you have two possibilities. And okay. So what is asked here is you have, let's say, 4 people, and these 4 people has to sit on a round table. So how many ways can you do this?
3 factorial.
3 factorial.
3 factorial. Right? So how did you get 3 factorial? Can someone tell me?
And because we cannot consider clockwise and anti-clockwise in this, so it is same. So n minus 1.
No, why did you get n minus 1?
Because we have to first set A
Ma'am, maybe one element
and then
fixed
after
that
he
was
can be
For
arranged
first person, we can arrange in a
linear way.
Yeah,
Mm.
for a first person, we can sit anywhere on the table.
yeah. And then whatever is left, now we have to arrange those people, right?
That would be a linear way.
Yeah, that would be linear way, and that is why it is n minus 1 factorial. And what happens in the case when the clockwise and anti-clockwise are same?
We divide by 2 factorial.
You divide it by 2, right?
Yes, ma'am.
Okay. So in this case, is n minus 1 factorial divided by 2. This is n minus 1 factorial.
Ma'am, can you repeat why is it n minus 1 factorial?
Yeah, because see, once, like, if you have to make people sit on a circular table, then if you fix one person, let's say I fix one person, then rest is linear, right? I mean, rest you can arrange the way you would do when the setting is linear.
Yes.
So the remaining is how many? Like, if you have 4 people, now you just, if I fix the position for A, now you need to just arrange D, B, and C here, there. And that will be sufficient, and that will make a arrangement, like possible arrangement for these 4 people.
Yes, ma'am.
I'm still unable to understand how this is different from a regular case. You have 4 positions and you have 4 people. So is it not 4p4? And if not,
Not,
why? I am still unable to understand, ma'am.
is it not 4p4? Okay. So let's make some figure maybe. So, okay. You have let's say A, B, C, D. This will have a lot of cases, but okay. Four factorial is 48. No, it's difficult to make 48 figures.
Let's take only 3.
Yeah, let's take only 3. So you have 3 people, A, B, C.
So we got 3p, 3 only.
Ma'am, like here we can see in second and third one. So there in if I'll check for B, so in the right side of B we have A and left side we have C. Similarly, in third option also in right side we have A and left side we have C. So we have to check on this criteria, not who is sitting where.
So like second, third, and sixth
Hello.
are same arrangements.
Yeah, so we have to check on like here right
Like
side
who
of
is
A
sitting
we have
next?
C.
Yeah, who is sitting next to each other? So they are
Ma'am,
different.
actually, you are not audible, ma'am.
Hello?
Yes,
Hello.
ma'am.
Can you hear me?
Yeah,
Yes,
yeah.
ma'am.
Yes,
Yes, ma'am.
ma'am.
Okay, yeah.
Yes, ma'am.
So no, this figure I have made this is not a correct figure. Okay, I did not make it correct. I just wanted to show the three distinct objects. If you have to arrange, this is what you have done in the linear fashion. And let's say I make it like this. But if you observe it, so as you said, right? I mean second the second one and so A is sitting with B and C, right? B is on this side and C is on the other side. And similarly, on the left of A again, it's left, right? On the left of A again, it's B. And on the right, it's
all,
again.
ma'am. Clockwise, no?
No, I'm just talking about left and right.
Okay.
So if I look at from the A's perspective, right? So, I mean, on the left of A, B is there, and on the left of right of A, C is there. Same in figure 2. On the right, it's C, and on the left, it's B. Then, if you look at the fourth figure, on the right, it's B, and on the left, it's C. So it is different than these two. Now, what is fifth? On the right, again, it's B. On the left, it's C. So these two are the same arrangements. And in this case, in the last case, on the left, it's B, and on the right, it's C. And this arrangement is same as this arrangement. And if you see this, the fourth and the fifth arrangement is same as the first arrangement. Yeah. So you see, it's repeating. It's not like what you do in linear. I mean, in the linear case, all these arrangements are different.
But ma'am, actually here, are we talking about who is sitting right or left to somebody, or are we talking about there are three positions and three people? How many ways can we arrange them?
We are talking about three people, three people, and we need to arrange these three people on a circular table.
Correct, ma'am. My point is, see, one side you're saying that okay, in one figure B is right to A, in another figure also B is right to A, and so they are same. But they are sitting in different seats.
They are sitting on different seats. That's right. But when you
so if instead instead, ma'am, if we give 1, 2, 3 two seats and A, B, C two persons, then we will know. I mean the number of positions, right? I mean otherwise instead of saying right, left, and all, yeah, 1, 2, 3 are the seat numbers. Now I have three people A, B, C. How do I arrange them? I can arrange them in 3p3.
You can arrange them in 3p3. So in that case, okay. Um, but what we're saying is the arrangement turns out to be like same. I mean, if you have to like, let's suppose you are sitting on a circular table, okay, and you're sitting with two people. So either you're sitting you're always sitting with the other two people, one people on the other side, other people on the like, let's say if this is you, these two are going to be some other person, right? But this will matter that whether this person is on this side, or whether the person who is sitting on, or the person is on this side, right? This will matter, right? That is the only thing that will matter.
No,
If
no,
you fix yourself, right? I mean, you have to look at from this is a very small example, right? The simplest one that
correct.
we can come up with, because if you increase the number, it's too big.
Correct.
So
But
hmm,
so we are ignoring the positions. I mean, we are not talking about 1, 2, 3. We are just treating them as same.
we're talking about the arrangements, like how many different arrangements are possible.
No, correct, ma'am.
Hmm.
But different arrangements means if you don't give number 1, 2, 3 and then start arranging them, then you are treating all three positions as same. You are not distinguishing them.
He's trying to say that you are not giving any number to these chairs. Basically, you are not considering that chair as first, that one as second, that one as third.
Yeah, I get that.
See, when there is linear arrangement, sitting position matters. If A is sitting on first one, so he is on the left end.
No,
But when
here,
it's
no,
circular arrangement, seat positions doesn't matter
no,
because
here
two people are next
also,
to each other.
no, here also the positions are, see, the way you put 1, 2, 3, 4, 5, 6 in linear, here also put 1, 2, 3, 4, 5, 6 on a table. Then you know, then you have the positions where who is sitting where.
We assign positions because in linear arrangement, positions matter, like who is first or who is second. But when we are talking about a circle, position doesn't matter. People are next to each other.
So in short, you can summarize it as in circular position of like chairs for your concern. Position of chair doesn't matter in circle if you are.
Yeah.
No, I mean, anyway, I am unable to.
Only relative position matters. We are considering position relative to A, relative to B, relative to
Yeah,
C.
it's
So
like
only
relative position. Like if you look at the linear case, then in that case, it's like it makes sense that okay, this can be one arrangement, ABC, ACB, all this we can do. So but in a circular, when you're talking about in a circular fashion, then in that case, it's more like uh, we want to see the total number of arrangements that can be possible on a table, because we are not really interested in like the exact numbers, like the position 1, 2, and 3 here. Well, because it's mostly that uh, there are three people, it's a three people, and we just want to arrange these three people. And if you want to just arrange these three people, there are only two possibilities. Hello?
Yeah, ma'am.
Ma'am, go ahead.
Oh, okay.
Oh,
Yeah, so yeah, the only thing is here, uh, there are three people, let's say, and if you are given to arrange three people, you're not taking the chair as the position, we're not saying this position is the first, this chair is the first position, this chair is the second position, this chair is the third position. We're not going in that way. You just want to arrange things. Okay, so if it is not very clear, maybe we'll try to come up with a better example for this.
Yeah, not clear, ma'am, actually.
Yeah,
Answer.
we'll come
Yeah.
up with a better example for this.
Okay.
Okay.
Yeah.
All right. Let's move to the next one. So I'll just skip these. Solve for n and solve for r. I think you can solve it.
What is that, ma'am? Solve for n, solve for r means?
Okay, let me just do one if you want. So for example, you have np4 divided by n minus 1 p4 equal 5 by 3. So you have to find, you have to solve for n. You have to find n here. So it's nothing, you just have to use the formula for permutation. So
Yeah,
you,
ma'am, we can do that.
Yes, ma'am. Yes,
you
ma'am.
can
We
do that,
can do
right?
that.
Yeah.
Yes, ma'am.
Same if I give something for r, you just need to find r. Okay. Then next comes the combination. So in the combination, we are only interested in selecting objects. We are not interested in like what order the object should come. That we're not interested in. We just want to select from a group of objects. Okay. The question here is, how many ways can we select 2 students from a group of 3 students?
3C2.
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 3C2, right? So you have 3 students, let's say A, B, C, and from there you have to just select 2. So it doesn't matter, whether the first student you selected is A or the second student you selected is B. So in this case, AB is same as BA, right? BC is same as CB and AC same as CA. So selecting 2 students, if you have to select, 2 students from a group of 3 students. There are only 3 possibilities, right? And how does the formula goes for this? So then what we're saying is number of possible combination of R objects from a collection of n distinct objects. So it is given by n choose R, and this is n factorial by n minus R factorial times R factorial. Okay. If I remove this R factorial from here, this is nothing but NPR, right?
Yes, ma'am.
So you select the objects and then R factorial is the number of ways to arrange those R objects. That's why we are multiplying it by just R factorial.
What is that, ma'am?
No, what I said is this NCR is same as 1 by R factorial times NPR.
Okay.
Okay. Then there are a few results that are important over here. So the first is n choose R is same as n choose n minus R. So it's like selecting R objects out of n object is same as not selecting n minus R objects out of n objects. Right? I mean, you select a R object or you reject n minus R objects. It's the same thing. So this is what this equation say here. And again, n choose 0 is just, it's going to be 1, and n choose n is also going to be 1. So many times you may come across questions where you'll have to do n choose 0, n choose n. So it's good to know, like it just comes out to be 1. Then the next is n choose R is same as selecting R minus 1 objects out of n minus 1 object.
Ma'am, choosing
Hmm.
0 objects from n objects.
Hmm.
How is that 1, ma'am?
Yeah, because it is just n factorial by n factorial times 0 factorial. And this is nothing but just 1.
No, but conceptually, I mean, how do we explain that, ma'am?
Conceptually, it's like because you have n objects. Let's say you have 10 objects and you don't want to select anything. And how many ways can you do it? Just one. I mean, you don't select anything. I mean, it's just 5. It's going to be 5. I know it doesn't make sense much, but I mean, selecting more objects, you have only one possibility, right? You don't select anything. Okay. Then the last one is selecting R objects out of n object is same as selecting R minus 1 object out of n minus 1 object, or selecting R objects out of n minus 1 object.
What is this, ma'am?
This is another inequality. So what we are saying is that either you select, I mean, if I'm saying select R objects out of n object, so this is same as selecting R objects out of n minus 1 objects, or selecting R minus 1 object out of n minus 1 object. So to understand this, maybe we can think of it like, suppose
What is the plus in between, ma'am?
yeah, I will tell you. So plus means either this or this, right? When you have either A or B, you add it, right? You add the two cases. So this is exactly the same thing it is here. So suppose I have to I have n objects, okay, and I want, or maybe let's say 10 objects total, and I want to select 5 objects. Okay. So any item that I pick from this set. So either, let's say this is the acceptance or selection set, whatever. Selection set, and let's say you put this is not selected. So let's say I pick an item. Let's say I pick an item A. Now either it can go there or it can come here. right? So if I fix one, like let's say, if this A gets selected, okay, if this A gets selected, then we have how many ways, how many objects left? We have 9 objects left. And out of 9 objects, now I need only 4 objects. Right? This is one possibility. Now, if A is not selected, if A is not selected, so still I have to fill 5 objects here. And since I know A is not selected, so still I have like I have already discarded this, and I have 9 objects left. And out of these 9 objects, I have to fill 5. So selecting 5 objects out of 10 objects is same as selecting 4 out of 9 or selecting 5 out of 9. Does this make sense?
Yes, ma'am.
No, ma'am, unable to visualize.
Visualize. Okay. See.
Ma'am,
ma'am. Yeah, tell me. I can hear you.
Can I ask some question? It's actually not related to this topic.
Can you just wait for some time? I mean, maybe it's almost getting over the concept, so maybe after that.
Okay, ma'am.
Ma'am, are you saying that selecting 5 objects from a collection of 10 objects
What
is same as selecting 4 objects from 9 plus selecting 5 objects from 9? Is that what you're saying?
Yeah. And how this has come is, like, let's say out of these 10 objects, right, we are interested in selecting 5 objects out of 10. So what we're saying is, if let's say I take one object from here, so I took, let's say, the object to be A. Okay. Now either it is selected or it is not selected. Right?
Yeah.
If I pick one object, I don't know whether it will get selected or it will not get selected. So first case, let's say it gets selected.
Okay.
So in case I select this A, then I have 9 more objects left.
Yeah.
And out of these 9 objects, you need to put 4 more here.
Yeah.
So 9 choose 4.
Yeah.
Now let's say A was not selected. So if A was not selected, then it means A will come here, and still I have 5 places to fill.
Yeah.
And I have 9 objects left. So 9 choose 5. Right?
Okay.
So this formula comes, this formula is useful in some cases. I think I don't have any problem with me on this, but sometimes this formula is useful.
Okay.
All right. One question. So it says in the exam, there are 12 questions. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. Okay. And it is divided into 2 parts. Part 1 has 7 questions. And part 2, this is, let's say, part 1. And part 2 has 5 questions. 5 questions, 7 questions. Now, a student has to attempt a total of 8 questions. Total of 8 questions has to be attempted, and selecting at least 3 from each part. So, from part 1, the student need to select at least 3. Part 2 also, student need to select at least 3. And total 8. So, how many ways can you select the question? How will you do
And
it?
5C5 7C3 plus 7C4 5C4
Hmm.
5C3 plus into 7C4 7.
Yeah, that's right. So it's not very difficult, right? I mean, we know one total of 8 questions, and you have two parts from where you have to take the question. So the first case that is possible is you take 3 questions from part 1. So selecting 3 questions from part 1 is 7C 3 ways, and if you select 3 from part 1, you have 5 more to attempt. So you'll have to select 5 questions from part 2. Then the second case can be you select 4 questions from part 1 and you select 4 questions from part 2. And the third case can be 5 questions from part 1 and 3 questions from part 2. So just add these 3 and this will give you a total number of ways in which the questions can be selected. All right. So next we have the question from cards. It says find the number of ways in which 4 cards can be selected from a deck of 52 cards.
And 52 into 51 into 50.
52C4.
52C4
Yes,
because
ma'am. 52C4. Yes.
Yes, ma'am.
it is 52C4. Now the next is, what if you have to select 4 cards, but what if all the cards have to come from, let's say, same suit, as in, like, let's say I'm talking about all the 4s are coming from let's say club.
13C4. How many clubs, ma'am?
4C1.
How many clubs in 52 cards? I don't know.
13.
Okay. How many of you know, like, how the cards?
Each suit will be 13. 4 suits, each suit 13.
Yeah. So you have total of 4 suits. So you have
Total 52, madam. Diamond 13.
club,
Club shape.
C4, ma'am.
Spade and ace. Same, madam.
what?
Spade.
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 Yes, yes. What is the last one?
Heart.
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 madam.
Yeah, heart. Right. And diamond and heart are red in color. So many times you get questions on that one also. So they are red in color. Maybe not now, but when you go to probability, sometimes it may come. And these are black in color. So each of these suits has 13 cards.
13, madam.
Now what we are saying is, what is the probability that all these 4 cards are coming from let's say this first. All the cards are coming from the same suit.
And 4C1 into 13C4.
4C1 into 13C.
13C4, madam.
Yes, ma'am.
Right? So
Yes, ma'am.
first you need to select
The suit.
one suit, right? So that will be 4, choose one. And then once you selected a particular suit, then in that case, after selecting the suit, you need to select 4 cards out of that, 13C4. But now if the question is all the 4 cards have to come from club, let's say, then
No,
what?
ma'am, actually, can you repeat this? Where, how is 4C1?
How is 4C1 times 13C4? You have to find, you have to select 4 cards, and all these 4 cards has to come from the same suit.
Correct.
So since 4 cards have to come from the same suit, it means first you need to select the suit. So there are 4. So out of 4, you need to select one.
Okay.
Once you select the suit, now you will go ahead and choose 4 cards out of that. Okay, that is why.
Okay.
But let's say if I'm saying, if I'm asking all the 4 cards are from, let's say, diamond, then what will be the answer?
13C4.
Just
13C.
13C4, because I'm also specifying the suit. You don't have to now go and select the suit, right? So that will be just 13C4. What about the last one? Cards are of the same
2C1.
Column, madam.
2C1 26C4.
2C1
6
26C4.
C2.
4. You have to select 4 cards.
Yes, ma'am.
So questions from cards are very common. It many places you will see questions from there. Okay. All right. What about this? You have total of 17 players. You have to select a cricket team of 11 players in which only 5 players can bowl. Right? And the team that you're going to select that should exactly contain 5 bowlers. Is the question clear? We are saying out of 70 players, we know there are 5 bowlers. Now you have to make a group of 11 players where there should be 5 bowlers. How can you, how many ways can you do this selection?
12C6 into 5C5.
Ma'am, further, don't we need to know how many bowlers are there in this 17 players?
5 bowlers.
No, it says you need to select only 5 players who can bowl, but it doesn't say how many players can bowl in the total 17, isn't it? Correct?
Okay, maybe it has written little different. Okay, from what we are saying is from a list of 17 players, select a cricket team of 11 players, and in this list of 17 players, only 5 players can bowl.
Oh.
It's not written. I got it. It's not written very properly. So what I'm trying to say is that out of the 17 players, there are 5 bowlers.
Okay.
And the 11 player team that you have to form, the requirement is that there are 5 bowlers.
Okay.
So how many ways can you do this?
So then should it be 13C11?
13C11.
Yeah.
12C.
Ma'am,
5C,
12C6 into 5C5
Because
yes,
or
13,
1.
Okay,
5C5 into
one
12C6
by one. So what is the first answer? 5C5.
30.
and 12C6 into 12C6. Yes,
12C6.
yes, ma'am.
Ma'am, we can ignore the 5C5 because it is same as
Just one, no? What is the second answer?
13C11.
Okay. And how did you get this?
Because you have 5 bowlers in 17, and you need to choose all 5 bowlers anyway. So I'm considering all these 5 bowlers as only one unit.
No, why? I mean,
You have to choose all of them anyway, right, ma'am?
yeah, I mean, you have whatever bowlers are there, you need to select them anyways,
Correct.
right?
So
So that is, there are 5 bowlers. You will select all these 5. Now, remaining, how many are left? Remaining, you are left with 12 players. And from there, you need to select 6.
yeah, okay, you have to, okay, from you have 12, from the remaining 12, you have to pick 6.
Because 5 is already there.
Correct.
Because if we do 13C11, there is a possibility that all the bowlers are not getting selected.
Okay, yeah. You got a good point. Thanks.
Yeah.
Okay.
Yeah, but they seem to be very tricky, each one.
This cricket question. All right.
NC3 into 3C2
NC3
into 3C2 because
which question you're talking about?
I'm the drawing line second.
Why it is NC3 trying 3C2?
Because we are selecting 3 points. For a line, 2 points must be collinear. So
No, I have asked you, you have n points on a circle. And how many lines can you draw connecting these points?
NC2.
NC2, no? I didn't give 3 points or something.
For a line, only 2 points are needed.
Yeah, for any line, 2 points are only needed. So you just need to select 2 points out of
9 n points.
N points.
it is given that connecting 3 points.
These points. It's not 3.
Yeah, it's these points. It's not 3.
Ma'am, now I can ask my question.
Yes, you can go ahead.
Ma'am, actually, I wanted to ask you about the reattempt of qualifier exam.
A reattempt of qualifier exam, okay?
Yes, ma'am.
Did you not
What
write
will,
the exam?
what, ma'am?
Did you not write the exam?
No, ma'am, I have given, but actually my maths marks are not good and I have scored above 80 in all the rest of 3.
Okay. So you want to give the reattempt?
Yes, ma'am, for maths. Actually, I've got 28% in maths and 80% in all of the 3 remaining subjects.
Okay.
So, ma'am, I have to give exam of all the 4 subjects or only of maths?
All the 4 subjects. I'm not really sure on that.
Only for math. Only for math.
For math, yeah, you have to give only for maths.
Only for math. You have to
No,
attempt
it's your
carefully math.
choice. It's your choice.
Yes, it's your choice, but mathematics is a lower. You have to attempt the mathematics and the qualified. Don't the three subject not attempt doesn't matter and attempt the better results. Okay, best of choose than the choose of the qualified.
Means
Both
I can
choose.
just it's up to me that I can give only maths or I can give the
Okay, okay.
whole of,
Only for math attempt and the submit. You can exam exist.
Yeah,
and
thanks.
it will
Thanks,
be
Gaurav.
of first to 4 week only, ma'am.
First 4 week
Yes,
only.
yes, first for week.
First four.
Actually, this term mathematics is a tricky question, easy question, but tricky question.
Yes, yeah, yes. And actually I want to ask मैम अगर मैं like क्वालिफायर की प्रिपरेशन कर रही हूँ तो मैम ये जो वीक मतलब 5 6 वगैरह की क्लासेस हो रही है तो वो भी मेरे को अटेंड करके असाइनमेंट्स वगैरह सबमिट करने हैं
No,
कि
no, no,
नहीं
no, no,
नहीं.
no, no, no.
तो वो
अगर बिल्ड
जरूरी नहीं
कॉन्सेप्ट
है.
कॉन्सेप्ट अगर बिल्ड करना चाहते हो खुद अपने से कि नेक्स्ट टाइम में हमको
हाँ.
अच्छा इस फाड़ना है तो आपका चॉइस देख सकते हैं, फ्री ऑफ कॉस्ट है।
अच्छा और बाकी अगर मेरा मतलब अभी सिर्फ मैथ्स का ही पेपर देने का होगा है ना.
हाँ हाँ, मैथ का ही देना होगा, आपका चॉइस है। जो आप मैथमेटिक्स में अगर लो है ना तो
हाँ.
मैथमेटिक्स का पेपर दीजिए, उसमें क्वालिफाई कर जाइए, फाउंडेशन लेवल में आप एलिजिबल हो जाएंगे। अगर आपका चॉइस है कि नहीं हम चारों सब्जेक्ट से फिर से देंगे और बेटर करेंगे रिजल्ट को, तो आप चारों सब्जेक्ट भी
अच्छा.
अटेम्प्ट कर सकते हैं।
अच्छा और इस बीच मतलब जब तक क्वालिफाई नहीं होता तो तब तक मैं सिर्फ 4 वीक का ही कर सकती हूँ मतलब
हाँ हाँ
मेरे को फाइव
हाँ,
सिक्स वीक का करने की जरूरत नहीं है ना.
नहीं नहीं जरूरत है।
तो
ये सब वापस.
क्वालिफायर में फर्स्ट 4 week ही आता है।
ओके मैम.
तो
मींस
जो भी
मतलब ये जो अभी क्लासेस चल रही है वो फिर बाद में
अभी
वापस
क्लासेस
होगा.
चल रहा है, अगर टाइम है आपके पास तो क्लासेस देखिए, उससे बेहतर होगा कि आपको ये चीज पढ़ना भी पड़ेगा आगे, फिर कॉन्सेप्ट
वापस ये
बिल्ड
सब
होगा।
रिपीट होंगे.
हाँ रिपीट होगा तो
so like
डिपेंड्स योर नॉट एनी प्रेशर,
yeah,
आपकी चॉइस है।
ओके.
hope that is clear to you. Yeah,
यस मैम, थैंक यू फॉर गिविंग मी टाइम.
yeah, thanks Aurav for clearing this out.
Ma'am, I have a doubt in a question I just commented on.
Yeah, go on.
I comment on that message section.
You send message. You get some other okay. Uh, okay. It says 5 classmates could not agree on who would stand in the group photo along with the teacher for the yearbook. Okay, how many possible groups can be made such that there is at least one student with the teacher in the photo? Okay. Okay, so how does this question go? Like it says, there are 5 students, right? 5 students, and there need to be group photo that has to be clicked, and like how what you have to find is how many possible groups can you make such that there is at least one student with the teacher in the photo.
Ma'am, where are you reading it from? I am not seeing it on the screen, ma'am.
Just look in the chart. In the chart, there are many questions. I think the last one. Did he send to, yeah, he sent to everyone. Wait. It's from graded assignment. No, graded assignment will not take. Thanks for pointing out.
Yeah, it's from graded assignment.
Yeah, please do not ask the graded assignment questions.
Just clear the question. Just explain the question what he
Just
trying to say.
explain the question. Yeah, so you just have to find out how many groups can you make such that at least one student, I mean, there can be one student also. So at least one student is there in the photo along with the teacher. I don't know what to explain here. Mm,
Can we answer this question by that at least method when we calculate the total number of ways and minus that ways which we not need to solve?
yeah, that you can think on that. That you're going right. Just think about it a little. So maybe there will be sessions solve with us where you do the problems very similar to graded assignment. So till then, please try. Okay.
Okay, thank you.
Yeah. Okay. So next is okay, so you have a question. It says there are 8 athletes and they're participating in a 100-meter race, which has several rounds. Okay. Now you have to give the awards as a gold medal, silver medal, and bronze medal. So how many different ways can you award the participants who went?
8C3.
8C3 or 8P3?
I think it should be C, ma'am.
It should be C. Okay.
Yeah, because
8P3.
Okay, why 8P3?
Because order matters. If first person is getting gold,
Gold.
then it's different from second
Yes,
person.
ma'am.
Yes, ma'am.
Yeah.
8P3, ma'am.
Yes, ma'am.
8P3.
P3.
Order of the prizes matter, ma'am.
Agreed. Yeah.
Uh,
8C3, ma'am. Second question, I think.
yeah, because you have to just select top 3. So that is just 8C3. Right? I think you
Yes,
can they are directly from the
How many different ways can you choose the top
right.
3
So you
athletes
can
to proceed?
maybe watch the lectures also because you're not doing anything. So you should just be able to understand like when should you use the permutation and when should you use the combination. I think you would also have seen those things. You have an extra assignment, right? EMQ.
Yes, ma'am.
Yeah, so there you will, I think, come across many questions on like steps. So I think that will give you better practice for the permutation and combination questions. So please, if you have not watched the lectures, please watch the lectures and work on the problems also. Okay. So how many of you have solved the practice assignment?
Ma'am, I have completed grade also.
Good, also good. So there are
Ma'am,
no,
anything more to teach, ma'am?
sorry.
Anything more to teach?
No, that was all. There, I mean, there is nothing more. There is no more concept involved in week 6. So that is all we have in week 6. And when you go to week 7, you will work more problems on. You will see probability. So how this
Yeah,
can
ma'am.
play a role in probabilities. Be good to see. So that is why this week is quite important because it will help you in week 7 a lot. week 7 and week 8 also. Week 7, week 8. It helps a lot. So are you guys referring to any book, any textbook for problems?
Yes, ma'am. That available on IIDM BS website. That is written by an instructor.
Okay.
That's all.
And apart from that?
No.
No?
Ma'am, any recommendation which book we can refer to?
You can refer to Sheldon Ross if you want. They have a lot of problems which you can work on.
Ma'am, can you write the name? I didn't get it.
I think ma'am has also suggested this. You would have seen this name, but I'll write it.
Ma'am, will you take doubt in next session?
Yeah, we'll take doubts in the next session. So next session we'll do only problems.
Sheldon Ambrose, ma'am. No.
Sorry? Yeah, Sheldon.
Statics.
Yeah.
Yes, it's about the course section.
Yeah. It is by Sheldon Ross.
Yeah.
It's quite popular, and there's you'll see a lot of problems.
Okay, ma'am. Thank you.
Yeah, thank you. Okay, so we'll close the session for today, and the next session when we meet, we'll solve the problems from week 6. So practice by then. I suggest practice so that it's easier for you also to, like when you see any new problem, you should be able to do it. Right? You should make such practice.
Ma'am, I have a small doubt. That spending time on that discourse DSA sessions that will affect our marks.
Spending time on discourse.
Yes, ma'am.
You're talking about the bonus marks that is given.
Yes, ma'am.
So for discourse, you get badges. So it will not affect your mark, but the discourse is there so that if you want, I mean, there is something if you are not able to, like many times, let's say you're studying something or you're working on the problems, you get stuck. So that time you have a platform where you can go and post a question, and someone, if they know the answer, they will write right there, right? So this is how you can use the discourse.
Ma'am, so the
But
badges
I
are any
held
good for us?
What?
Or is it just any, like the badges we get after spending time on discourse? So are they any beneficial to us?
I think we can add it in resume, right?
Yeah, I mean, all those things you can do, but it depends on you. Like if you want to engage with other students, it's a good way. It's a good platform for you to engage, right? I mean, you will find many students who might have the same doubts that you had, or if you know the answer, you can clear the doubts for the students, right? So it's good. If you are interested, I would suggest please go ahead and participate.
Okay, ma'am.
Okay. All right then. Thank you guys for joining.
Thank you, ma'am.
Thank you,
Thank you,
ma'am.
ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am. Night, ma'am.
All right.
Thank you, ma'am.